All right, here's the review for the quiz on analyzing and graphing exponential functions and logarithmic functions. Okay, so for number 1 and number 2, you're going to identify the key parts of each graph. Number 1, it says the graph below is of an exponential function. Now, why am I telling you that? Am I telling you that for no reason at all? No, I'm telling you that so that way you know this one's going to have a horizontal asymptote, not a vertical asymptote, because exponential functions have horizontal asymptotes. So the horizontal asymptote, remember, it's always y equals a number for a horizontal line. So it's going to be y equals some number. And the number of the horizontal asymptote is going to be -1. I know it might look like it touches -1, but it doesn't. If you were to say that it's y equals -2, I guess I will understand that. But this one is going to be y equals -1. The domain is the x values in this graph. And this graph is going to keep going to the left forever, very slowly. But it is going to keep going to the left forever and hit every x value to the left. And it's going to keep going to the right forever. So for the domain, I'm going to say -infinity to infinity. Always put the smaller number first. Always put parentheses around infinities and negative infinities. The range is the y values in this graph. And the y values in this graph go from -1, but not including -1, because the graph never touches -1. It goes from -1 up to infinity. And since it's not touching -1, I'm going to put a parenthesis next to -1. Increasing intervals means where is the graph going uphill? Where does it have a positive slope? And it does not have any increasing intervals, so I'm going to write down none. Decreasing intervals means where is the graph going downhill? Where does it have a negative slope? And you use the x values, remember? And everywhere it's going downhill. Very slowly, but it's going downhill over here. So for decreasing intervals, I'm going to say -infinity to infinity. End behavior. What's going on at the two ends of the graph? As x approaches -infinity, and as x approaches positive infinity. Well, as x approaches -infinity, so as x gets smaller and smaller, the graph is going up. The graph is going up. So I'll say as x approaches -infinity, f of x approaches positive infinity. Okay. And what happens as x approaches positive infinity? So what happens as x gets bigger and bigger to the right? The graph, f of x, is approaching the asymptote of -1. Okay. One more like that. The graph below is of a logarithmic function. So again, I'm not telling you that for no reason. I'm telling you that so that way you know that this one's going to have a vertical asymptote, not a horizontal asymptote. This one's going to have a vertical asymptote because it's a logarithmic function. And the equation for that is always x equals a number. The number is -6. The domain is the x values in this graph, and the x values go from -6, but not including -6, to the right up to infinity. So a parenthesis next to the -6, because it's not included in the graph. The graph never actually touches -6. That's the asymptote. The range is the y values in this graph. This graph is going to go down forever, and it's going to go up slowly forever. So the range is all numbers, so -infinity up to infinity. The increasing intervals means where is the graph going uphill? And it's going uphill forever, everywhere. And you use the x values, so you say -6 because the graph does not go to the left of that. -6 to infinity. Decrease the intervals, whereas the graph going downhill, there are none. And finally, the end behavior. What's happening at the two ends of the graph? One of them is as x approaches infinity. The other end, x never approaches negative infinity, okay? So the other end is going to be what happens as x approaches negative 6. Well, as x approaches negative 6, the graph is going down towards negative infinity. And as x approaches positive infinity, the graph is going up, so the graph is approaching infinity. Okay. All right, so that page was analyzing graphs. Now we're going to do two graphs. One, we'll do a graph of an exponential function, and the other we'll do a graph of a logarithmic function. Okay, so if you think back to Unit 2, families of functions, I think we did this. This minus 7 means we're going to be shifting down 7. So normally the asymptote is at y equals 0. But since this one is shifting down 7, the asymptote is going to be at y equals negative 7. So if you want to graph that, you can. Maybe put like a dashed line there. But I'm not going to do that. I won't do that. So what x value should I choose? I'll do 0. I'll do 1. And I'll do 2. And I'll do negative 1. And I'll do negative 2. 1 second. Okay, so let's do the easy ones first. Let's do 0 first. So I'll do this down below. 4 to the 0 power minus 7. What's 4 to the 0 power? Anything to the 0 power always equals 1. So 1 minus 7 gives you negative 6. Let's do 1 because that one's easy. 4 to the first power minus 7. 4 to the first power is just 4. Minus 7 gives you negative 3. Let's do 2 next because that one's also easy. 4 squared minus 7. 4 squared is 16. Minus 7 gives you 9. Great. We got some of the graph going on right now. Let's do 4 to the negative 2 power. And then we'll do 4 to the negative 1 power. Four to the negative 2 power, and then minus 7. 4 to the negative 2 power is the same as 1 over 4 squared. 1 over 4 squared is the same as 1 over 16. Minus 7. So if you want to make that a decimal, you can, or you can just use fractions. I'll go with the decimal for right now. Let's say that's negative 6.9375. Now let's do 4 to the negative 1 power. 4 to the negative 1 power is the same as 1 over 4 to the positive 1 power. We talked about that a lot in this unit. So 1/4 minus 7. You want to get that decimal. 1/4 is 0.25. Minus 7 will give you negative 6.75. So as you can see, the graph looks like it's approaching negative 7, but never actually touching negative 7. As you can see in the table, which I told you before we even started the problem was going to happen. So let's graph the 5 values in the table. I'm going to move my page up here. Look at the table below. 0, negative 6. We'll graph first because that one's easy to graph. Then we had 1, negative 3. We had 2, 9. Then we had negative 1. negative 6.75, just estimate that. And negative 2 is negative 6.9375. The only thing is when you graph it, you have to make sure, don't extend your graph below negative 7 because that's the asymptote, okay? So look, let me do it and then I'll show you. So your graph should look like that, okay? It's not actually going to go below negative 7 on the y-axis because that's the asymptote. Okay. One more. Let's graph this logarithmic function. Now, normally the asymptote is at x. Is this the y-axis? X equals 0. If there is a number inside the parentheses as part of the argument, suppose it was log 3 of x plus 5 in parentheses, right here, then that would be shifted left 5, and it would change the asymptote. This one is not being shifted left or right. It's being shifted up 2, but that's not affecting this asymptote, okay? What affects this asymptote would be if there was a number inside the parentheses with the x. So I can tell you the asymptote right now is going to be x equals 0. Let's pick some x values that I know are going to be easy to help us with the logarithm. Okay. All right, so I'm going to say that 1 is a good x value to pick. You'll see why in a minute. I'm going to say that, let's say, actually, you know what? Let's do 1 down here. You know what? Let me redo that. Let's do the 1 right there. Actually, I lied. Let's do the 1 right there because I want to go in order in my table. So let's put the 1 right there. I'm going to do 3. And you'll see why I'm choosing these values in a minute. And then I'm going to do, let's do 9. Let's also do 1/3. Let's also do 1/9. Okay. So why did I choose those x values? Because those are going to be x values that are easy to get the logs of. Okay. For example, I guess we'll start with the easy ones. Let's start with 1, 3, 9, and we'll do the fractions. Let's do x as 1. When I do x as 1, here's what I have. 4 times log base 3 of 1, because I'm doing 1 for x, plus 2. What is log base 3 of 1? In other words, 3 to what power equals 1? The answer is 0 because anything to the 0 power equals 1. So this equals 0. 4 times 0 is 0. Plus 2 equals 2. Let's do x equals 3 next. So let's do 4 times log base 3 of 3. I'm just replacing the x in the original problem with 3. What is log base 3 of 3? In other words, 3 to what power equals 3? The answer is 1. So 4 times 1 plus 2 equals 4 plus 2, which equals 6. Let's do 9 next. 4 times log base 3 of 9 plus 2. What is log base 3 of 9? In other words, 3 to what power equals 9? The answer is 2. See, I'm picking x values I can easily do the log of. That's why I chose 1, 3, and 9. So 4 times 2 plus 2 is 8 plus 2 equals 10. And let's keep going in our table. Let's do 1/3. Let's do 1/9. So let's do 1/3 next. 4 times log base 3 of 1/3. Log base 3 of 1/3 means 3 to what power equals 1/3? -1. Let me make it look nice. I'll use parentheses. Looks nicer. So be consistent. 4 times -1 plus 2 is -4 plus 2, which equals -2. -2. And let's do x is 1/9. 4 times log base 3 of 1/9. 3 to what power equals 1/9? -2. So we get -8 plus 2, which is -6. So I put -6 in my table, and let's graph these 5 values. So we'll do the easy ones first. 1, 2. I'm going to move my paper up. The next number in the table below was we had 3, 6. In the table below, we also had 9, 10. And my asymptote is going to be right here because I'm not shifting left or right. So we have 1/3, -2. Right there, maybe. That's good. Then we had 1/9, -6. Like right there, I guess. Looks good. So let's draw our graph. All right, so that is the end of the quiz review. It was on analyzing and graphing exponential functions and logarithmic functions.